Hi everyone, and welcome to Snowden's presentation of kriging neighbourhood analysis and drill hole spacing analysis. To use these two modules in Supervisor, we're going to create two statistics. The first is the kriging efficiency. This measures the effectiveness of the kriging estimate to reproduce the local block grade accurately. The second statistic we're going to create is called the slope of regression, or the conditional bias slope. This summarises the degree of over-smoothing of the higher and lower grades. For a more detailed explanation of both of these, you can go to Snowden's website where there's a white paper, or the white paper is also located on Snowden's LinkedIn page. The first module I'm going to talk you through today is the kriging neighbourhood analysis, or KNA. As you can see already, I have my variograms set up, and that is because the KNA will use the variograms to help calculate the statistics for kriging efficiency and slope of regression. So to add it in, just click on your continuity models, right click, add, and there's the KNA option there. By using the KNA, what we're trying to do is optimise our input parameters for our estimation. And the input parameters we're going to look at are block size, the number of samples, our search, and our discretization. The first of these parameters that we're going to test is the block size. And over on the right hand side, under the blocks tab, we have an area where we can enter the block sizes that we want to test. Before setting our different block sizes, we should have a look at our drilling. There's a tab up here for the 3D viewer. If I click on here, I'm now looking down in plan view on my ore body. This is a very flat tabular ore body. The drill holes are on a nominal 80 by 80 metre spacing with a few areas here that are closer spaced. So if I go back to my KNA and my block sizes, I'm going to set a block size of 80 by 80, and I'm going to keep 2 metres because it's a very flat tabular ore body. I'm also going to try 40 by 40 by 2, 20 by 20 by 2, and I'll try 10 by 10 by 2. I'm also going to try all of those combinations, but this time with a spacing of 4 metres in Z. So I've got 80 by 80 by 4, 40 by 40, 20 by 20 by 4, and 10 by 10 by 4. Any that you don't want, you can just highlight and hit delete. Once you're happy with the block sizes that you've got, you can hit the update button. We now have all of our results charted for those different block sizes that we used. On the left hand side in red, we have the kriging efficiency. On the right hand side in blue, we have the slope of regression, and across the bottom we have all the different block sizes that we've chosen. For our kriging efficiency, what we're aiming for is a value above 80%, and for the slope of regression, we're aiming for a value above 0.9. Now please remember, if you're in a high nugget deposit or deposits where the drilling is very wide spaced, you probably will not reach these values. But what you can do though is compare different scenarios to see which gives you the best. You can see here that the larger block sizes, the 80 by 80 by 2 and the 80 by 80 by 4, have given us the best results for the kriging efficiency, and all the slopes of regression are approximately the same. If you want to know what these values are exactly, you can just hover over there and get the statistics that you need. I'll just show you two other tabs down the bottom here. One is the results tab. What it does is it does an ordinary kriged estimate of that block. There's a whole series of results here, block covariance estimate, estimation variance, sample count, etc., etc. I'm not going to go through all those, but if you want to, all those results are here. And if you want to do further analysis, you can right click, export, and you can export that to a CSV. Another tab that we have down the bottom is the negative weights tab. In blue on the right hand side we have the count of the negative weights, and in red on the left hand side we have the sum of the negative weights. If we go back to the main tab there for the kriging efficiency and slope, I'll just show you some other features here. We have a sort by here. We can either sort by the scenario, kriging efficiency, slope, or the negative weight sum or the negative weights count. So for example, the kriging efficiency there or the slope there. Another feature we have here is a show summary tick box. If you tick that on, it has a summary of the XYZ centroid for all of the blocks. They all share the same centroid. Number of samples, search ranges, search angles, and discretization. I'll explain more about this a bit later. The default for the block centroid I can show you in the 3D viewer. So if I click on here and I get rid of my axes, it is the exact center of all of the X, Y, and Z coordinates, as you can see here. I'll show you later on how we can move the block around and do some more KNA analysis. We can now go back to the main KNA window. To do the next step, we need to first of all choose which block size we're going to use to run the number of samples, the search, and the discretization. For this particular example, I'm going to choose the block size 80 by 80 by 4. I can now double click on that, and that will take us through to a new window where we can test the number of samples. Over on the right hand side there's a samples tab, and we can set up the minimum, the maximum, and the step. The minimum I normally just put 1, and a maximum of about 40 or 50. In this case I'll use 50, and a step I can use a step of 1. So this will give us samples 1, 2, 3, 4, 5, 6, etc. up to 50. If I hit update, we now have the kriging efficiency and the slope of regression for all the different sample scenarios that we've chosen along the bottom. So you can see here pretty quickly, if we choose say 1 or 2 samples, we're going to get a very poor kriging efficiency and a slope of regression. So I would recommend say at least 3 samples. Now generally with the maximum, as you can see here, once you get to say about 28 samples, there really is not much improvement in either the slope of regression or the kriging efficiency. So for this particular example, I'm going to choose a minimum of 3 and a maximum of 28. When you've done that, you need to choose a lower and a higher, and then double click. This will take you through to the next window. In this window, we're going to look at our search ranges. The third option here is always the ranges that you've set in your variography. The second option is 90% of this. The first option is 66% of your ranges. Option number 4 is 150%, and option number 5 is 200%. So just for this example, I'm going to run with the defaults, but if you want to add some more or delete some, you can do that easily in there. So update. We can see here they're all about the same. So I'm just going to stick with the ranges that I've set in my variography. So if I double click on that, that will take us through to the next window for the discretization. Now remember, for the discretization, it has to make some sense with the block size that you've chosen. So the block size that we've used here is 80 by 80 by 4. So we're not going to use a discretization of 3 by 3 by 3. We should use something, for example, 6 by 6 by 1, because it's very flat in that Z dimension. I might get rid of this also. I might put 5 by 5 by 1, and I'll just put in 1 by 1 by 1 to show you what happens there. And if I hit update, we now have our kriging efficiency and slope of regression. I'm just going to choose the 6 by 6 by 1. Now that we've done the KNA testing for all of our parameters, we can go back to our KNA tab here on the left hand side. Up on the right hand side here, there's a parameters tab. This is where we can set the final parameters that we want to use for all the different block sizes. There's the block centroid, which I showed you before. There's the search angle. For this particular example, angles are 0, 0, 0. Now, if for some reason you want to change the angles, you can just tick off that box and type in whatever angle that you want to use, but I'll just use the defaults for this. The ranges, we used the ranges that were the defaults for the variography, which was 1,840. Once again, if you want to use something different, you can just click on this and change it as you want. I'll just use the defaults. The number of samples we used a minimum of 3 and a maximum of 28. Now we also have the option here of using the maximum number of samples per drill hole. You can tick that on and off if you want to use it. To be able to use this, you will need to import the drill hole ID. If you do not import the drill hole ID, you won't be able to use this option. For this particular option, I'll leave it off. And the discretization we chose was 6 by 6 by 1. When you've done that, you can hit update. And now we have all of our parameters that we've chosen for the KNA for all the different block sizes. We also have our, if I go back to the blocks tab, we have our show summary tab left on still. So it tells us the block centroid, the samples, the minimum and maximum, the search range, search angles, and discretization. For the KNA, we should test different blocks in different positions throughout the ore body. If we look here, we can see that our block is just in the middle of our ore body here. We should move it around to several different places because there's different drill spacings throughout. The easiest way to do this is just to copy this. We can do that by right-click, component, copy. Go back to the continuity models, because remember the KNA comes in under the continuity models. Right-click, component, paste. That adds in a second KNA component. We need to update that, and we go back to our KNA. If we go to the 3D viewer, there's a KNA tab. Now there's two ways to move the blocks here. We can actually physically type in some coordinates and see where it moves, or we have sliding scale adjustments where we can move our block around. I'm going to move it into this spot here. I'm going to zoom in. Now remember, because our deposit is very flat and tabular, we need to check the Z component, and that looks quite good. Now we can go back. All our parameters have already been set if you want to use the same ones, and we can just update that. Then we have our KNA statistics, kriging efficiency and slope of regression for that new position. If you want to compare these results with the first results we've done, you can just simply hold down the control key and click on the KNA for the first one. Now you can make a comparison of the two results. So you can see here, by using this KNA module, you can quickly test different block sizes, samples, search distances and discretization, and you can mix these combinations around and make many different comparisons. Now that we've finished the KNA, we can have a look at different drill grids with our drill hole spacing analysis. So our drilling for this particular project is approximately 80 by 80 with a couple of areas of 40 by 40. But we could say, okay, what would happen if we had a 40 by 40 grid, or what could happen if we had an 80 by 40 grid? We can create any grid that we want, including bigger grids. Maybe we want to use 100 by 100 or 150 by 150. And then we can create all these statistics for kriging efficiency and slope of regression, and then compare them. The first thing we need to do is to add a drill hole spacing module. We do this under the continuity models, right click, add drill hole spacing analysis. The first thing we need to do is to generate our drill grid. I'll take you through several of these to give you several examples of how this is done. The first thing we need to do is set up our drill hole grid. On the right hand side here we have a drill hole spacing analysis tab. Under here we need to set up the direction of our drill holes with the azimuth and dip. Then we have the major direction. We need to set out the distance and then the drill hole spacing. The same in the minor direction, and for the downhole direction we can set the end of hole depth and then the sample interval down the hole. I'll run through some examples now of how this is done. So for example, if we have holes that dip at 60 degrees to the east, we can have a dip of minus 60 and an azimuth of 90. If we go to the 3D viewer now, we can see our drill holes here when we zoom in. They are all dipping at 60 degrees to the east. If we go back, we might have holes that have a bearing of 135 and they dip at minus, we'll just say for example 45. If we go to the 3D viewer now, view from the top, we can now see that all the holes dip at 45 degrees at 135. You can set up any parameters that you want to use here. For the particular example I'm doing, I'm going to go back and I'm going to set up a grid, an azimuth is 0, and my holes are vertical, so I can make them minus 90. In the major direction, I'll just show you how these work. If I make this a distance of 3,000 and our drill hole spacing is 80, I can show you what this looks like. If I go to top view, you can see how it's really elongated in that X direction. If I go back here, 2,000, and if I go to the viewer again, you can see how that affects. And you can set up any grid that you want here. For the data that we have here, I'm going to go back and I'm going to set up a grid that is 40 by 40. I'll make this a bit smaller. I'll make that 1,000 and I'll make that 800. That was what the defaults were. And if you want to change your downhole distance and your downhole sample length, you can do that here if you like. I'm just going to leave it as it is. Now that you've got your drill grid set up, it's just the same as the KNA that we've done before. So we click on the KNA. The first thing we need to set up is our drill grid. Our drill spacing is 40 by 40 now, so I'm going to have a 40 by 40 block, 30 by 30, 20 by 20, 10 by 10. Then I might have a 40 by 40 by 4 block, 30, 34, 20, 24, 10, 10, 4, and I'll delete those last two. When you're happy with that, hit update, and once again you get your statistics for kriging efficiency and slope of regression. As before, choose a block size. We'll choose the 40 by 40 by 2. Double click on that and then you can set up your number of samples. I'll do this the same as before also, which was 1 and 50 in steps of 1, and update. When your number of samples come up, you can pick a minimum and a maximum. So for this example, I might choose a minimum of 8 and maybe a maximum here of about 24. Double click on that when you're ready. To do your searches, as before, I'm going to run with our default searches and update. When that's done, I'm going to choose our third option here, which was the default search, which is set at the ranges for the varigrams. Choose that, and then we can set up our discretization. There's a default there of 333. Remember our blocks are flat, 40 to 42, so I might choose 6 by 6 by 1 and maybe 5 by 5 by 2. Update. 6 by 6 by 1 looks good. When you've gone through all your parameters, you can go back to the KNA window, select the parameters tab at the top right hand side. We had samples of 8 to 24. Our discretization was 6 by 6 by 1. And if you want to use max samples, you can do it here. Just for this particular example, I'll leave it off. Then you can update. Now that you have your first drill hole spacing set up, if you want to do another drill hole spacing, you can just simply click on to drill hole spacing here, Control C for copy, go back to the continuity models, that's where this is, Control V for paste. We can go back to our drill hole spacing and now set up a different drill hole spacing. For example, this time I might do 20 by 20. Then if you want to use all the same parameters, all you need to do is hit update. So there's an update everything under the component there, so I can hit that. Once you have all your drill hole spacings and KNA set up, you can now compare them all. To do that, you can just click on your KNA there, and if you hold the Control tab, you can get the second KNA up, the KNA for the drill hole spacing number 1, and KNA for drill hole spacing number 2. You can now compare all your results that you have. Thank you for watching Snowden's presentation of Kriging neighbourhood analysis and drill hole spacing. For more information, please contact Snowden. Thank you.